Hi guys, today we're back to transforming some quadratic functions. So here I have an equation in standard form, and we have to graph that function first, and then we're going to see how in number 2, g of x affects f of x. All right, so starting with f of x equals x squared minus 2x minus 3, we can pull that up. We can see how it's graphed. We press the table, and then we can actually do the graphing on our own. So it looks like our vertex is at 1, -4, so we'll graph around that. So we could do -3, 12, which is here, and then -2, 5, which is here, then -1, 0, which is here, 1, -4 is here, 2, -3 is here. Oh, I skipped 0, -3. There we go. And then 3, 0, 4, 5, and 5, 12. So there is our quadratic function, which in this case is kind of going to act like our parent function, even though x squared is typically the parent function. This is now the equation that we're going to transform. So we're going to name this one f of x, right? And we're going to now change f of x according to g of x. So that's saying to take f of x and add 3. So now g of x is x squared minus 2x minus 3 plus 3. And that minus 3 and plus 3 cancel out. So we could just say g of x equals x squared minus 2x. Now, we know that plus 3 on the outside is a vertical transformation. Okay? You should be able to remember that. So my guess is that that's going to move f of x up 3 units, but we want to prove it. So now we're going to pull up that graph. And I'm just going to delete the minus 3 at the end. Then pull up the table. And now we see that our new vertex is at 1, -1. So we can start there and build around. And then -1 and positive, nope, 0 and 2 are both at 0. -1 and 3 are both at 3. 4 and -2 are both at 8. And we could get up to 15, let's see. Nope, we can't. So that's going to be it. So this is g of x. And as I assumed, it did shift it up 3 units. You can see that every point on my purple graph is now up 3 units higher on the blue graph. Okay, so we can say, how did this graph of f of x change to get g of x? It shifted up 3 units. And again, you should be able to see that just because of the plus 3 on the outside here. All right, so let's take a look at another example. Number 3. So now we have f of x equals -2x squared plus 8. So we're going to start with that. Pull up the table and look for the vertex, which is at 0, 8. So we have 0, 8 right here. And then around that, -1, 6 and +1, 6, -2, 0 and +2, 0, and -3, 10 and +3, 10. So this is a pretty narrow function, and again, that's because of the 2 on the outside. So it looks like that, and we're going to label it f of x again. So this is going to act as our parent function this time. And this time, h of x wants us to multiply the entire f of x by -1/2. So we're going to do h of x equals negative 1/2 of negative 2x squared plus 8. Now, I could really leave it that way, but I'm going to rewrite it. So h of x equals negative 1/2 of negative 2 is positive x squared, and negative 1/2 of positive 8 is negative 4. So my new equation is going to be x squared minus 4. So we can pull that up. Y equals, clear again, x squared minus 4. Pull up the new equation. And now our vertex is at 0, negative 4, which is here. And then building around that, we have negative 1 and positive 1 at negative 3. And negative 2 and positive 2 at 0. And negative 3 and positive 3 at 5. So it looks like this. And that is our new g of x. So now we have to talk about all the things that happened in this case. So first of all, you should notice that our first one was pointing down and our next one is pointing up. So that means there was a reflection over the x-axis. And we should also see that our new purple function is a little bit wider than the blue function, and that's because of the 1/2. So it was also widened by a factor of 1/2. And that's all, again, given right in the h of x equation. We affected f of x by negative 1/2. We reflected it because of the negative, and we widened it because of the 1/2. All right. So hopefully you're seeing how I'm getting these. It's not too challenging, but it is definitely something that shows up very often. All right, so you're going to complete 5 and 6 on your own. Hint, replace all x's in the original equation with x plus 3. Keep that x plus 3 in parentheses.